By now we know what branches are, and hopefully you at least have a feeling that they can be a great tool to isolate logical units of change. The next question that might come up is, what do we do with those units of change? For example, a bad idea that is technically totally possible is to just keep creating new branches from the last one and treat the latest branch as your current project state. Probably most of you already have a couple of thoughts why this is a bad idea. Again, we are not really going to talk about best practices on branching yet, but one thing is so obvious that it is even represented in its name, and that is that one way or the other we will have a main branch to which we will have to integrate our changes from other branches. So independent of any branching strategy, the general pattern will always be something similar to what you can see here. The process of integrating the changes from one branch to another branch is called merging. In our picture, this happens in two places denoted with the black lines, here and here. From what I'm showing you in this small picture, you might get the impression that this is just another small, rather simple step. But trust me, it's not. When projects grow and more people or whole teams have to collaborate, merging can become a major bottleneck for progress. There are whole technologies, patterns, and books dedicated to ideas how to effectively merge. And terms like merge hell came up because it's very easy to do it wrong. This is maybe the actual core of this course and of any other version control mechanism. But before we open the very large best practices box, let's again first see how it works from a purely technical point of view in Unity and Plastic. For a reason which you will understand at the end of the video, I want to keep it very simple this time, and the only changes I will make to the Unity project are empty scripts where I only care about the script name. So let's say we start to work on a first feature of our new game, and so we think that it's a good idea to create a branch for this feature. I will represent this feature just with some script called feature A. For our current discussion, it doesn't matter what the actual feature is. Now, as we learned in the branches lesson, this feature is just existing on the current branch. The main branch doesn't know anything about the feature yet. So once I'm done with my feature and I think that it should go to the main project, I can choose the branch or a change set on a branch and select merge from this change set too. I can now choose the branch into which I want to integrate my changes. We don't have too many options yet, but we know that we want to merge into main. A new window opens up, which is giving us some tools to review and understand the changes that will happen to the main branch. This is an important moment because if we have done something wrong, so far this is only affecting our isolated branch, on which we may be working alone. Once we finish this merge operation, however, those arrows will also affect the main branch, which is probably also used by other people, or if you're working alone, had the working version of the project so far, which now might be affected. So make sure to take your time and try to understand the changes that you introduce. In the main window here, we can see that our change is adding 2 new files to main, and that is what we want. On the top right, we have an option called Merge Diagram. This seems very simple. For now, it shows us that we will merge into main, and that this will create a new change set. We can see 3 new terms here: base, source, and destination. Those terms are at the core of how the Plastic merge algorithm actually works. And for those of you who want to go really deep on Plastic, there will be an optional video for that. In short, Plastic needs those 3 change sets, base, source, and destination, in order to understand which changes need to go into the merge. For your everyday work, however, particularly when you are just starting, it's enough to know the terms source and destination because they help us clearly understand in which direction the merge is happening. In this case, we wanted to merge from the only change set on the feature A branch, which makes this change set the source, and we are merging into the main branch, which makes the last change set of the main branch the destination. In this very simple case, the destination is also the base, but that will not always be the case in more complex scenarios. And again, for now, let's not worry about the base at all. The button to the right offers some settings for the merge, but those will also be easier to understand once we have some experience with merges. The default settings are fine for most cases. Once we are done with our review, we can check in the merge and see the result in the Branch Explorer. If you look closely, you can see that a merge is a special thing because it creates this green arrow, which is pointing from the source to the destination. This is called a merge link, and we will also briefly cover it when we look at merges under the hood. But from a practical perspective, it's enough to see this as an indicator that a merge happened here. Notice that after the merge, the destination is an actual new change set, which is only created through the merge. When we check it out, we can now see that in Unity we have the same state as on the feature branch, which means that the new script is now also present. Okay, that was one way to merge in Plastic. There's also another way. For that, again, we create a new branch for a new pseudo feature. We add a new script and check in. But this time I will first switch to main. And now I can choose the change set from which I want to merge. So it's sort of the other way around. I'm not saying into which branch I'm merging, but rather from which branch I want to merge. We then get a similar window as before, but if you remember this button from last time, it now has a different text. It says Apply Changes. And what happens when we click it is also different than before. You can see that the merge link and the destination change set are dotted, which means that they are in a temporary state. In this state, we can check the changes we would introduce first and then confirm the merge by checking in. So in Unity, we could now test if the project behaves as it should, run the game, and so on. In our case, it's as easy as identifying the feature B script and then check in. The final result is the same as with our first merge. The last thing I would like to show you in this video is that obviously we are not restricted to merges into the main branch. For that, let's first create another branch with a feature exactly as before. But this time, let's imagine that in the meantime, we find a bug on the main branch. Maybe some other dev wants to fix this and add some magic bug fix script to the main branch. Now let's say that we find out that we actually also need this bug fix before we can finish our feature. In order to do this, we could merge the main branch into our feature branch, which will also add the bug fix script to our branch. Now we can finish our feature and proceed just as before. So technically, there are no real restrictions on how you can merge branches. Obviously, just because you can do it doesn't mean it's always a good idea. That's it for a primer on merging. Unfortunately, it's just the beginning of the story. I told you at the start of this video that in order to make the examples very simple, I only used scripts to represent the changes. Can you make a real Unity game that way? Obviously not. In Unity, a lot of our work will happen in one or more scenes. And in the next video, we will explore why merging scenes is a totally different story than what we did here.